Okay, what we're going to do right now is we are going to derive or determine exponential regression model based on two ordered pairs in exact radical notation. First off, what are we going to remember is exponential again is y equals a b to the x. No different than doing a linear model would be y equals mx plus b. The first thing we're going to do is write these out as a system. We're going to say 6 equals ab to the 8th. Okay. We're also going to say 4, being the y value, 4 equals ab to the 5th. Now when you divide out these systems, it's a little bit different. We divide the numbers, and we get 3 halves. I just like to reduce when I can. A over a cancels out, and 8 take away 5. When I divide powers of the same base, I subtract exponents numerator down. So I get b cubed. That's great and all, but I want b, not b cubed. So I'm going to take the cube root of both sides. And what happens is I get a lovely thing there. I do want to rationalize that though if I can. So I'm going to say the cube root of 3 over the cube root of 2 is still equal to b. Down here, this little bugger, I got to fix that. One of the easiest ways to do it is to say 3 take away 1 is 2. So I know when I rationalize, if I multiply by the cube root of 2 squared, top and bottom, it's going to work out very nicely. 2 squared is 4, and 4 times 3 is 12. So I now have the cube root of 12 over. Now this gives me right here the cube root of 2 cubed. And you remember that cancels out. So here we go. I just solved for b. That was not too bad, you have to admit. So up here I'm going to say y equals a b to the x. Again, this was b. So we have the cube root of 12 over 2. Halfway done. Now the fun stuff. Okay. So now we take this b value and I put it in here, and I want to solve for a. I could go here, but the numbers are bigger, so I don't need to do that. I can stick with a better equation. So I'm going to say 4 equals a times b, again b being the cube root of 12 halves to the 5th. Now this looks a little scary. You're thinking I have to write this out 5 times or whatnot, but if you remember your exponent rules again, this 5 jumps in up top and jumps in down here. So do I have is 4 equals a times cube root of 12 to the 5th all over 2 to the 5th. Okay? And you're like, wow, that looks terrible. Not too bad. We are going to multiply both sides by the reciprocal. And again, remembering from Algebra 1, that will eliminate this mess. I'll have a all by itself. So right here, we are going to have 32. 2 to the 5th is 32 over the cube root of 12 to the 5th times 4 over 1. Again, this being the 4 over 1. And that'll be equal to a. 32 times 4 would be 128. So I have 128 over the cube root. Let me just clean this up for a second. The cube root of 12 to the 5th. And again, that equals a. The trickiest part from here is saying that denominator is pretty bad. 3 goes into 5 once. That means 1/12 comes out. 2 are left over. So now I have this right here. Let me slide this back over. When I go to rationalize this now, I can do the same trick I did over here. 3 take away 2 is 1. That means when I rationalize, I have just 12. 3 take away 2 is 1, 1/12, right? So I put that here also. When I multiply the top across, I get 128 times the cube root of 12, like we saw. But right here it changes to the cube root of 12 cubed, correct? 2 plus 1. And that cancels out also, leaving me with a 12. But it's this 12 times this 12 that gives me 144. That'd be kind of a common mistake to forget that 12 there. When I want to reduce this math right here, we can start off easy and just say, well, half of this, half of this. No one deals with this, right? No, no, no. Yes. So I get 64 over 72. I think I could take an 8 out and speed it up a little bit. So I'm going to get 8/9 and the cube root of 12. Jumps right there. I'm actually done. I wasn't that bad with it. So I have 8 times the cube root of 12 all over 9. I do realize that not everyone loves radicals as much as I might. If you had to use a graphing calculator technology or computer or whatnot, your approximations would be, I already did them out if I can find it, I believe this would be 2.035 and this would be approximately 1.1447. You're missing all the fun though. I think all this is way funner than just plugging in a calculator, but either way, get the same idea. That concludes determining an exponential regression model in exact radical notation. More to come later. Bye.